So let's move to demo part. I'm going here and I'm opening in incognito mode. So I would highly recommend whenever you're working with Google Cloud, always work in incognito mode. Otherwise your Gmail address will interfere with the email that you want to use. So I'm just using console.cloud.google.com. So this is the URL where you will find we have this kind of dashboard. This dashboard is actually showing you different services of Google Cloud. You can even search on the global search. So now you can actually access the artificial intelligence platform of Google through two ways. One way is you can actually go to the common bar, this search bar. This is global search. You can perform search here. You can write artificial intelligence platform, AI platform, or you can do it through these three bars on the side navigation bar. So in the navigation bar, you will find, you need to scroll down and you will find AI platform there. So what I will be doing, I will be searching for this AI platform from the search bar rather than going via navigation bar. So this is the navigation menu. So in navigation menu, you will find there are so many products of Google, and one of the product is AI platform. Here in the machine learning products, you will find somewhere AI platform. This is big data, and then this is artificial intelligence, and here you will find AI platform. I am doing pin. So when I do pin, I can see AI platform is now bookmarked here. I will click on AI platform, or I can search for AI platform in the search bar also. Our focus is AI platform, so that's why I'm more focused towards like this particular product rather than showing you multiple other services of Google Cloud Platform. So on the AI platform, you will see there is a dashboard, and in this dashboard, you will find there are so many options. Like one option is you can label your data. So this is one of the labeling service, data labeling service provided by artificial intelligence platform. So data quality is very important when it comes to artificial intelligence. So if your data quality is bad, then what will happen? Like your AI will not be so accurate. You will face issues. So that's why we recommend that the quality of data should be great. So like what this service is doing. So this service is basically you can give your data to Google, and Google will involve manual labeling. Labeling data. Like let's say in a picture we have many objects. So these people, these are actually manual workers. Like this is a manual work which is being done. So behind the scene, you can actually say that the humans are actually doing this work. You are giving the data, you are giving your images, videos, text, and this will basically be then converted into a well-labeled data set for your AI. So this particular service is now available maybe for like limited. It's not like a highly available service because of COVID. The manual labor is not available so much. So that's why this particular service is not so much promoted right now. If you go to the documentation also for data labeling service, you will find there is a disclaimer written in the red color that the service is not available or available into very limited availability of the service, because the human labor is not available. And this thing is done by Amazon also, and Amazon calls it as mechanical trunk. So every cloud provider has a different name to mention this service, and this particular service, you are giving the data set, you are giving the label set. Label sets is basically you are saying that let's say in my pictures I have three types of objects. You can say table, chair, and tree, right? So these are three labels. So you will be defining your labels in the label sets. So you will be specifying like table is one category, chair is another category, and then third category is tree. So you can define these labels here, and then you can give the instructions to the manual labor who will be doing the labeling of your pictures. These instructions will help them to know like what exactly you want to do with the data, right? So sometimes there is confusion also. You are saying chair or sofa. So are you saying sofa is also a chair, or so you need to write these instructions so that it is very clear to those people like how to label the data. So this is one service which is very important because quality of data is very critical for successful AI. So this is data labeling service. Apart from that, I want to show you in AI platform, we have notebooks, and these are models. Let's go to the notebooks first. So now I'm going to another interesting thing. So I will be creating a new notebook instance. So I will be saying plus, and I will be creating a virtual machine. So I will be creating without GPU virtual machine, but you have other options also. So instance name, you can give any name. So right now I will just give data couch, and I will specify region. You can specify which region you want to go for. Let's say I go for Mumbai related region. So let me see. I will just pick up this Asia, South, East, and zone. I'm just keeping it as is, and this Singapore region, and I'm just specifying the environment. And environment I'm picking as 2.1 TensorFlow 2.1, and you have other options also for choosing like PyTorch, or if you want to use XGBoost or any other. Okay, so this is like environment I picked up, and then I can change the machine configuration. Right now I'm using trial version of Google Cloud Platform. So in case you are interested to know how to set up this particular account, how to set up free trial account for Google Cloud Platform, you can watch a video on our YouTube channel where you will find how to create a free trial account for GCP. So using free trial only, I'm doing everything. So I will not be using GPUs in this particular case because my deep learning model that I will be showing is simple. It does not require GPU. So I will not be spending my free credits on GPU. And I can even change boot disk or networking option permissions. I will not be going into these details because it's more like customizing the things. But for the timing, I'll just say create. So you have many options to customize. You have, okay. So this is like small lowercase. So this is all done. This is all done. I will just say create. So this will spin up a machine, and this virtual machine, if you are using GPUs, then it will have pre-installed GPU drivers also. If you are using TensorFlow 2.1, then it will have those libraries pre-installed, so you don't have to worry about installing these things, dependency, like which version of Python, which version of TensorFlow, maybe which version of NumPy, which version. So you don't have to worry about these things. So it will give you a standard set of libraries which are required to run TensorFlow 2.1. So once that is done, then you are into the virtual machine and you can install your own libraries. So let's say I want to install a specific library into the virtual machine. You can do it very easily. I will show you how to install your own libraries into the virtual machine. But right now, this machine is being created. So let's see. I'm going inside the VM. Can you see it is going into a compute instance, compute engine. Okay, so let's go to the Jupyter Lab. And this environment is very similar to what you have on your local systems, like when you run Jupyter notebooks. So this particular environment, you will see we have many options to actually install your own custom libraries. So you can start the Jupyter notebook and you can perform experimentation there. In the custom library, I was mentioning like you can install your custom library. So this is the option where you can install your custom library. So you can just use a terminal. So I will click on the terminal. And in this terminal, you can say that I want to install something. Let's say I am doing pip install. Let's say I'm installing XGBoost. So this will install this particular library, and I can also say file, new, and I'm saying notebook. So when I open a notebook, and if I say import, okay, I will say Python 3 notebook, and I will say import XGBoost. So you can say this is just installed, and I'm able to import XGBoost here. Maybe I'm just doing as XGB. So this is done, and I will say XGBoost XGB dot underscore underscore version underscore underscore. So it will show me the version of this library which I just installed here, and this is 1.1.1, and I'm able to use this library in my experimentation using this notebooks. So right, so this is one thing, like how to use custom libraries in AI platform. I can also basically git clone. So I have the URL. Let me pull out that URL. Give me a second. And I will use my GitHub, and from GitHub I will basically be retrieving a notebook. So let me do git clone here, and I will specify that URL here. Yeah. So this is done, and I will say clone. So when I clone, it will ask for my username, password. I'll just specify that. It looks like private repository. So I'll just log into my GitHub, and it will do the cloning. You will see one more folder has been created seconds ago. It was not there. So I just use this option of doing git clone. So after this, you will find that I have a deep learning experiment, and this deep learning experiment is related to FashionMnist. So this is like having documentation along with the code. So in the documentation, a lot of things have been specified. You can read it offline also, but for the time being, what I will do, I will give very quick walkthrough. So first of all, what is MNIST? You might have heard about MNIST, MNIST dataset. MNIST dataset is basically, MNIST stands for Modified National Institute of Standards and Technology. Modified National Institute of Standards and Technology, MNIST. So this MNIST is like hello world of deep learning. And you know, whenever you learn something new, you write hello world program. So this MNIST is actually hello world because, you know, this is handwritten digits. So these handwritten digits, you will find the data set is having, I will show you how it looks like, handwritten digits. So let me go back, and let me show you the images, MNIST images, how they look like. So these MNIST images, you have 5, 1, 9. So in computer vision, when you start learning computer vision, then you will be writing these kind of programs, and you will be understanding like what is written, like you are writing with your own handwriting, and you are identifying what is a text written or what is a digit written within that picture. So this is MNIST dataset, but we are not using MNIST dataset. We are basically moving one step ahead of MNIST. I'm using FashionMnist. So FashionMnist dataset, it's related to clothing, and we are classifying these clothes into 10 different categories. So let me go back in the notebook. You will find we have clothing category, and these clothes are basically having 10 categories, and these are pictures of clothes. So our computer vision, our deep learning model will understand like what kind of clothes we have in a picture. So there are 70,000 grayscale pictures, and each picture is 28 by 28, and these are low resolution pictures. So these pictures we have divided into 60,000 pictures related to training the model, and 10,000 pictures for evaluating or so testing the model. So here you can see we are loading this data set, and this data set is part of the Keras. So this is bundled with the Keras, and Keras is basically like a high level wrapper over TensorFlow. So this particular Keras library is actually under the hood, it is running TensorFlow only because TensorFlow 2.0, if you see TensorFlow 2.2, 2.0 has already got this. So let me rerun it. When I'm rerunning it, then it will show me the actual version of TensorFlow, and TensorFlow 2.0 onwards, Keras is like a recommended way of working with TensorFlow because the code is very simple to write or understand. So you can see we are using TensorFlow 2.1 because when we were creating the virtual machine, we used TensorFlow 2.1 option when we created our VM in the Google AI platform. So it's already pre-installed. We don't have to install any TensorFlow or any NumPy or any other library, standard libraries for. But if you want to install your custom libraries, you can always do pip install. But standard libraries we already got. So this is done. And this is okay. And then Fashion MNIST, you can see we are able to segregate the data. There are 70,000 pictures, and these 70,000 pictures, we are downloading it from Google Storage APIs, and then it is basically be coming into this in particular VM. We are downloading it. So it will take some time, but for the timing, just understand the code, what we are doing. We are getting the data. We are dividing this data into training set and testing set. And then we have these 10 categories. So some are t-shirts, some are trousers, some are pullovers. So there are 10 different categories. So these are the class names that have been given. This is called multi-class classification that we are doing. And then we are finding like the shape of the training images. There are 60,000 images. So this is training data set. We will be training our model, machine learning model, deep learning model on 60,000 images. And then each image is of size 28 by 28. So that's the shape of this particular tensor. And here we can see the labels. So labels will vary from 0 to 9. If you see the list, this is 0 to 9. So we are using these labels, 0 to 9. And these labels have been assigned, and then we can get the shape. The 10,000 images are for testing. So we will be testing. So let's say we want to see what is there in a particular image. So 0th image, you are basically having a shoe. If you change it to 1, then you will see some other image. So let me see if download is complete. If download is complete, then we can play with this also. But it's still downloading. It will take time. So let's not waste time in that. So you can play with this notebook offline, but just understand that you can actually introspect the data. You can understand the data, like what exactly is there in a particular image, and you can plot it, you can show it, and you can specify the index, and you can see like whether we have the correct label for this particular picture or not, or how the picture looks like. So you can analyze that. Now after that, we are doing scaling of our pixels. So the pixels will vary from 0 to 255. So we are just dividing it by 255 so that the values will range between 0 to 1. This is very helpful for training our model faster. If you don't do it, then there are chances that model may not converge, and then you will see like the training time is also longer, and it is not very helpful to you. So this is one of the things that we always see whenever our machine learning model is taking long time and it's not converging, and then you can actually consider doing normalizing of your pixels, right? So this is one of the things that you can consider. Okay, apart from that, we transformed our data pixels, and then we are actually looking at our data again, and then we are just looking at few pictures. This is okay. These are the labels along with pictures. We are just showing it. After that, we are building a deep learning model. Okay, why 255? 255 because this is a pixel, this is RGB value. No? So RGB value can vary from 0 to 255. No? Okay. So this is sequential model, and this Keras model, we are having first layer, second layer, and third layer. So these are deep learning neural networks. So deep neural networks. So here we have a couple of layers. So first of all, we are flattening the input shape. So ideally, we should not be doing it because, you know, if you change an image from 2D to 1D, then what will happen? You are losing a lot of meaning. So that's why we have convolutional neural networks. So this is not the best example, but this is hello world of artificial intelligence. So that's why we start. This is not like, this is second level, not like basic level. Basic level was like MNIST, basic MNIST, but right now we are dealing with Fashion MNIST. So this is better than basic examples, but we are flattening. I'm just highlighting this thing. Flatten is converting 2D to 1D. So 28 by 28, it will be like 784 pixels. You're converting in like 2D image, in like you're flattening all the pixels in like as an input. You're giving input to the machine, deep learning model. And then we have a hidden layer ReLU, and then this hidden layer we has 128 neurons, and this is again a hyperparameters. So we can tune these hyperparameter. You can find out like what should be the optimal number of neurons in a particular layer. So using hyperparameter tuning, but for the time being, just see like we are giving 128 here, which is like the number of neurons in this particular layer. And then last layer, which is the output layer, has 10 neurons because there are 10 classes and each neuron will represent one class. So hope this is a clear, like output is having, why output is having 10, this is important, and why input is having 784. So we are compiling the model here. We are using optimizer, and this is Adam optimizer, which we are using for optimizing our this is a gradient descent process, like in case you are familiar with that. And then Adam optimizer is actually helping us to converge in an optimal manner. So this is an Adam optimizer that we are using here. And then here we are defining the loss, and it is cross entropy because it is a classification example, and in classification cross entropy is used. And then metric is accuracy, so we are using that here. So we are just defining model parameters, and then we are training our, this is fit means we are training our model. When we are training our model, we are defining number of epochs as 10. So we will be going through this data set 10 times, like 60,000 images. We are going through 10 times. That means 6 lakhs samples we are scanning or going through. So this is 10 epochs. The epochs is basically how many times we will pass through the entire data set, that is epoch, right? So we are training our model, our machine learning model is learning that, and then we are evaluating our model, and then we find that accuracy is 88%. So we have, 10,000 images. Using 10,000 images, you will be evaluating, you will be finding whether it is giving the results correctly or not for those 10,000 images. And then you will be making predictions, and these predictions, like you give a new image and then you see whether it is giving you the right results or not. So you can see the output. Can you see the prediction is having 10 numbers? Why 10 numbers? Because there are 10 classes, and these 10 classes, highest value of this, you can see this one, argmax is giving you like which particular index is having the highest value. And this 9th index, this is 0.9 because e raised to a minus 0.1, this is 0.9. So this one is having the highest value. That means this particular thing is related to this, this particular category. And last category, which one is the last category? 9th category. If you go up, you will find last category was 9th category number array was ankle boot. So that's why it is giving this 9. Okay, so this is fine. We just saw, this is just showing the predictions, very fine. And this is ankle boot. Okay. So this is how the softmax function looks like. Yeah. So right now we can see like we are able to perform experimentation. This is how we work.